questions. I'll begin by again welcoming you all and certainly welcoming our speaker today, Dr. Wufeng Tian. Dr. Tian is an assistant professor of mathematics at the University of Wisconsin-Eau Claire, Barron County. He loves teaching mathematics and using a variety of teaching strategies to instruct students and to promote student success. He has taught a wide range of mathematics and statistics classes. His research interests are in applied and computational mathematics. He's been working on high-order numerical methods for solving partial differential equations, mathematical modeling, numerical methods, and fast algorithms for structure and solvation analysis and molecular biology systems. He definitely enjoys working with students on undergraduate research projects. So thank you, everybody, and thank you, Dr. Tian.
Hello, everyone. Can you hear me? Yeah, I think so, right?
Yes, you sound good.
Okay. Hello, everyone. Today, I would like to share with you the undergraduate mathematical research and activities at Barron County we did. So the purpose of giving this talk is I would really like to share this with the students and the faculties at Eau Claire campus. And maybe since right now we have another program which is also launched at Eau Claire, like it's called lunch program. I'm teaching here every day, like every week now. So in the future, we'll probably have more opportunities to conduct these projects or research activities together as well. So first, I would like to. I have a lot of slides, but I can't go all of them. So first, I would like to give you an introduction about what I'm going to introduce today. So first is basically a brief introduction about why I'm doing this. And second is the mathematical modeling contest and student research league, and then the Smart City, Smart Future competition we did last year, and the impact, which everybody knows is Mayo Clinic and Eau Claire, and some other student research dissemination opportunities. And then finally, thank you. So why do I do the undergraduate research? Like conduct this undergraduate research, why do I enjoy working with the students? Because I think this is important. I remember when I was an undergraduate student, I did like this, I participated in these activities, and then gradually, okay, I think I made a decision to go to graduate school to continue research. So developing and maintaining undergraduate research programs benefits students and faculty members, and then also our university as well. First, it helps the students and they develop their critical thinking and writing skills and communication skills. It really helps them to improve those skills. Secondly, it challenges students to clarify and analyze and propose application solutions to open-ended real-world problems, which there's no solution, no exact solution. I can say there are many solutions, but there's no okay, this is like a solve equation, you have exactly one solution. There are many different possibilities, right? And then it also provides students a distinct advantage when they're applying for your future internships. So when they go to when students go to the industry or go to a company for interview, they can tell when they have the interview, can say, hey, I've done this before, and I have this experience in these projects. They will have more to talk and more to tell people to present themselves. So next one is faculty. As a faculty myself, I also learn from faculty perspective. So if we work together, students sometimes provide me some different perspective view on a certain projects. So, and also then the last is also our school, university. Like when I did some research, if it's really good, like we have very good outcomes, we can announce it in the newspaper and some media and to help like our university to showcase of our good activities at school. So university benefit from presentations, publications, or serve to increase our visibility in the academic community as well. And when we recruit students, we go to high school, the high school student, oh, I see this school, I heard this story from, like, for example, Barron County, I heard this before. So the first projects I did at Barron County was the mathematical contest in modeling. So the mathematical contest in modeling is an international contest in high school students, college undergraduates. Every year it has, they give you several questions, 6 open questions, like a real question, there's no solution to it. And the student have to submit a paper. And this contest attracts diverse students from like over the world, 900, more than 900 institutions. I see UW-Madison, I see like big university like Princeton, Harvard, and like big universities really participate, Yale, participate in this contest. And I don't see many, I don't remember, I don't see any team from Eau Claire yet. But since I was in Barron County, I have a team from Barron County participated. So in next year, the contest will be in 2021. It's going to be February the 4th to 8th, and students can participate in it. So if any students is here or any students is watching this video, if you would like to participate into this contest, participate in these projects, please contact me. I forgot to tell you. You can see all my project details or in my webpage, or you can email me if you're interested in any of the projects that I introduced today. So this is sponsored by Mathematical Association of America and the Society of American Statistical Association, American Mathematical Society, like all those sponsors. And this contest, we have not won we haven't won that cash prize yet, but the prize of this project is if they won the 4 top teams will get $10,000, $9,000 goes to students, and $10,000 goes to the school. No, $1,000 goes to school, $9,000 goes to the students. And then they also have other small prizes like cash award or other prizes like other certificate stuff. Okay. So our school, we participated twice last year. No, twice last year. Once every year, like we have participated twice. So in 2018, 2019, the project was mathematically and biological reasoning, a game of thrown dragons. So basically, it asks you to mathematically or biologically to assume that dragon is real. So how big would it be? And how does it work? How does the dragon breathe fire? And how much food does it need? And what size of community do we need to raise the dragon? And then when they have this is the TV show, if many of you have not watched it, you probably heard it, like Game of Thrones. So they have 3 dragons in the TV show. So why do they want to do this? Because when they really know this, when they write the fiction, if you're major English, when you write some stories, or if you have some math background, it makes it more scientifically, okay, it's pretty much more interesting, like, oh, it's real, like, it's more fun, right? Like, if you say, oh, the dragon is like a building, it's really big. Oh, how big do you want? Like, how much food does it need? Like, it's kind of like have more details, more scientific way to write a story. It shows, I think it's more interesting. People probably want to read it more. So our students, what they did is they first drew those pictures drawn by the students. They drew these 2 pictures themselves. So how the dragon looks like and how it produced the how it have the fire, like breathe fire. So first, when you breathe fire, they need the fuel system, because to have a fire, you need a fuel, right, to burn it. And then second, you want ignition, like like to ignite the fire. So students drew this picture. They think about how can I have a fuel? For example, what is the fuel? The fuel right now we know is gas or some other. The wood obviously is not possible to breathe such a fire. You get like so much energy, right? So what the students assume, they think maybe the best fuel we know is methane. So they think that as the stomach right here, the red part, the blue is the part which they have like the concentrated methane. So if they breathe, and then on the mouth there is kind of like an ignition system. Plus minus, if they bite it, they have the electric statics, and then with the fire, when you start your car, positive negative, you can do that, right? So some fish can really do this. I will not introduce the details about the fish, how that fish really in the sea they can breathe the fire, have the electricity, like how can they do that? So what they do next, they use a modified growth model, a composed growth model, and then before this activity, before this contest, we actually did have a meeting with my students. I have the student meeting with my student before the contest. We have the meeting with my student every week, every Friday, and we have a seminar or like study workshop every week. I give them a presentation. I teach them some models, and then sometimes they ask them to share their work in progress. I give them a topic and ask them to prepare. So some of the models they know it before. Well, if they don't know it, they ask them. You have to learn it right now, like Google it, and it's just a model. They find it online, and they use that model to first they assume that dragon, how big it is, and then from the dinosaur point, they assume that it's 650 kilograms. And then they draw the growth curve, like at the beginning it grows faster, and then when they grow really mature, it don't grow anymore. And then based on the Kleber's law, they find out the energy, how much energy it needs, like based on the body mass, how much energy does it contain. And then based on the, because the dragon, the TV show needs to fight. So some days it fight, some days they rest, but it can't fight for 7 days. When they fight, it breathes fire. So they take the equation of the energy equation. If they fight 7 days, how many calories they need. If they don't fight at all, how many calories they need. Then based on the chemistry, the methane and the oxygen they burn have energy, produce water and carbohydrate. No. And then they calculated they calculate the energy and they say how many energy it needs, and then they find out, okay, so calorie, they need to take it from food, what they eat. So they eat from, for example, goat, and how many goats they need to, one goat produce how much energy, and then how many goats they need to eat every day, and then find the size of the community, and then they find out between 17, based on the rainfall, like amount, and how much grass they grow, and annual rainfall, and how many goats it can raise. So they give a lot of more details. This is just the main idea of this paper they did. And then our student, when they honorable mention winning that projects, and among the 14,000 teams in the world, I remember there were 8 teams from Madison. I think 2 of them won some award, and the 6 didn't win much things. So when you don't win anything, it's just you get a successful participant. And then last year, in 2019 to 2020, we have the problem is what makes the help of online review. So if you look at this thing, these 2 pictures, you can tell it's very familiar, right? What is it? Amazon. So when you go to buy something, what do you really want to look? You look at, okay, this product, let me see the review. Oh, the review is good. Oh, let me see. First, you look at the pricing, look at the review. Obviously, you don't want to have something is all one-star review, like 74 people, like 74% of people give you 1 star, and that product obviously is not a good product, right? You don't want to buy it. So this customer review is really important. But what happened is that when the company has the data review, like a review data, how do they know which data they are going to be looking for? So for them, from the company point of view, they want to improve their product, right? They want to improve their product. So based on the data they have over 20,000 reviews there, like maybe even 30,000 reviews. So how do they get the useful information? There's no way they're going to read the 30,000 reviews one by one and find the information. Okay, this is what I want to improve. Or sometimes it's not real, like the review is not like actually reflects your product feature, right? So how do the company to review, to look at the data, and how can this help the company to improve the product and to get a more share in the market, right? So what we, as a customer, when you look at a review, you also can see, oh, this review is helpful to me. There's another thing after this review. There's another helpful, not helpful. This is a helpful review or not helpful review in that review. So for a customer, when you review them, you can do several things. You can review it and you'll say helpful, not helpful, and you can write down your review. Sometimes you can give a feedback. So what this project really wants us to do is wants the students to give the company a suggestion. How does the company will be efficiently use those reviews? And so let me give you an example. Look at this is a review of a company. They give a lot of data to the students. So this is the example, like the business, the customer review this, traveling on business often allow me to try quite a few hotel hire dryer over the years, blah, blah, blah. Okay, so I'm not going to read the whole thing. We will go back to look at is this review helpful or not helpful, right? Well, how do we know that? So what really makes a helpful online review? So first one is the articulation. Is this review right? Like when they read the review, does it really make sense? Right? Does it grammatically or English like articulation? Does it really say something people understand? The second is relevance. Okay, I bought a product of past fair, and now it's write a review of another product which is not relevant to the product they bought, right? A third one is objectiveness. So when they make the review, is it sound like objective, or is just they personally don't like it? And the last one is word count. If you write like 1,000 words, nobody will really have a time to read your review like 1,000, like a dissertation. No, not really. People don't want to read it, right? Or if you just write a word, oh, good product. That's not much information about the review, right? You didn't really say much about it. You say, okay, I know it's good, but in what aspect, right? So the students think about the review, they discuss about it. Obviously, they still have a team. They discuss about it, like what makes the review like helpful. So what the next thing is, okay, so we have like 10,000. So you receive 10,000 reviews, like a number, like words. How do I convert those quantitative reviews into quantitative score, like 1, 2, 3, 4, 5? Because when we talk about math, it's numbers, right? We have to convert. So all of those reviews are quantitative things, like words. There's no math there. The only math you have probably just the average or standard deviation of those stars, like the 4 out of 5. That's the only thing you have. But in terms of the detail of each review, it's just English words. It's quantitative variables, the quantitative reviews. We want to convert that into quantitative score. So student establish a rubric, like 1, 2, 3, 4, 5. Like articulation 1 to how like there is a rule they establish a table on each of them. Relevant, very extremely relevant is 5, like not really relevant at all is 0. Like all of those, they give each review a point, a score. They first build up a rubric, then based on the rubric they give each review a score. Well, obviously the student can't do like 20,000 reviews gave all of them. So they used the statistics method, is randomly stratified sampling method, and selected 100 reviews or 200. I don't remember exactly how many reviews they selected, and selected those reviews, and based on their rubric, they have the scores for each review on each item, articulation, relevance, and objective word count. And then they use the multi-regression model and have the model for each category, for each variable here. So X is a score of the objective list, X2 is a score of articulation, X3 is the relevance to product, X4 is the score of the word count, X5 is the star rating. So in the end, they finish that analysis, find the p-value, find the f-value, and then they also plot the residue plot, and they have the model. And then in the end, they test it, like if my model is really good or not good. So in the Amazon review system, they do have actual outcome, how many people feel is helpful review. So based on their model, they have the predicted like 92% people will feel this is helpful. And the actual people, actually they have 93% of people feel this review is helpful. So when they pick up several reviews and verify that model, and in the end they pick up there are a lot of graphs like this. I just selected one. So they select the top 3 microwave start rate. So they gave a student different products, several products. One of them is a microwave. So they have the time-based review. So the top 3, you want to know the time-based review, the average star is going upward, going down, going average. So how the trend looks like. And if you are a company, now if your product's the time series, like a time-based, the mean value is going this way, means okay, it's good. If it's going the worst one, they also have a worst 3. I didn't put it here. And if it's worse than 3, I need to pay attention. So from the company point of view, they give a company a strategy how to find out the helpful review, how to improve, how to monitor their data, and how to improve their product based on the review. So this one, I didn't put a picture of them here, the student team, the picture I normally do, but because of the COVID-19, the students, I have the student name here, we have the certificate, and then basically the top 15 in the US. I think there are 100 teams, maybe 15, top 15 have been honorable mention winner, which is really nice in this contest they did. So next one is the Student Research League, this is just specifically for 2-year colleges. Maybe it's not good for the Eau Claire student, they probably can't participate in it, but obviously you can learn some of the problems, right? So one of the in the 2019, the projects the student did, like, is mathematical analysis of the alternative power system in northern Wisconsin home. You probably have read this in the news. What they did is first they predicted the electric rates based on the electric. Later, actually, one of my students is working on this. One of my students is still working on this project right now. So basically, they predict the electric rates over the next 30 years. And then they find the solar panel system in the summer, you have more sunshine and you have more power in the summer. And then if you have wind power, how much wind do we have in Wisconsin? And the student find the cost of the hybrid system and how much does it cost to install the hybrid system, and how much what is the environmental benefits. So they give all the details of the average of the emissions of the Wisconsin tracked by 2007. So they put all the data in and did the data analysis for the environment and also cost benefit analysis as well. And then they proposed that a solution for the Wisconsin resident if you install the solar panel and wind power. So what are you supposed to do? And in the 30 years, they said they can save about $41,000 in the next 30 years if you use this renewable energy system. So right now we are talking about, I think our school also have the sustainable energy, right? Goal in 2050, 2025 or 20 something. I think it's 2025. We have several plans for the sustainable energy. So this is a really relative topic, and the country, the whole world actually really focus on the renewable energy right now as well. And so next one is the Smart City, Smart Future competition we did at Barron County. And this one could be done at Eau Claire as well. Because of COVID-19, I think they canceled this year's competition, this year's Smart Future design. But I think it will come back next year when the COVID-19 is gone, hopefully. So it's sponsored by UW System, Foxconn, and YSIS. I think it's all of this. I think you probably know better than me all of those companies. We participate into this one, and the students design a Smart City, Smart Future competition. So design a stop sign. I don't think I have time to play these videos. You can go to my webpage to watch those videos. I'm sure it's really fun to watch those videos about the student design. So our students, basically the stop sign is we design a stop sign in the winter. It will melt the snow. It covers by snow, it will melt. And the stop sign, when you approach the stop sign, if you don't stop, it will remind you a signal here says stop. And also have a camera system. If you don't stop at stop sign, take a picture, will give you a ticket. Obviously, people don't like it, right? But that helps with the driving habit. So if you don't stop, you will take a picture. So I actually work with UW Fayetteville about this project, and we designed a prototype product in the spring. Since with Eau Claire does not have really big engineering program, so I worked with the Platteville students and faculty. We work on this product, and YSIS support us on this product. They put some money into it. So we won the final round. I think the Smart City, Smart Future, we won the grand prize winner, and we won $5,500. And the other one is the e-home, which is based on the previous previous Wisconsin Energy Home. We have another design for the home, and then they also win the top 10 finalists. The student got like $3,000 as a prize after they do this. The next one is the impact. I think the impact, everyone is familiar with the impact, which is the Mayo Clinic. Student and faculty work together on the Mayo Clinic. Every year they propose a topic. Maybe this year they're going to do COVID, I don't know. So they give a topic, and students work together and review the topic and propose a idea or propose a solution to this problem. And then they presented at Mayo Clinic. And in 2019, they did this is the 2019, what they did here, and we have a team picture. And 2020, students also did again, another team, obviously. They did the mechanics links between the binge alcohol drinking addiction and the function of the neural immune system. So one of the students is planning to go to medical school in the future, so she really wants to do it. And another student wants to do psychology. Another student wants to do business in the future. So we have 3 students, and they also present this. This is their poster. You can see that picture. Some of the pictures, some of the research is from online, the existing stuff. Some of it is their own idea. So they have a post behind them here, and you have we have team picture with the chancellor. And the next one, I would like to spend a few minutes after the way. So the student and faculty research collaboration, I think this student and faculty also know this. We have this. I also had one student did this, the mathematical analysis of renewable energy and sustainable energy in Wisconsin. So I also did it with the student continuing research. It's based on this one, continuing research of these projects. We won the national award, second place in the nation. Student got $1,500 over this topic of the mathematical analysis of alternative power system in Wisconsin homes. So one of the students continued the projects with me, and he transferred to Madison. a lot of students in my team actually transfer to Madison because at Barron County they can't stay there for 4 years. Most of them transfer to Madison after they finish my projects, which I can understand, but I hope maybe in the future they can stay here, stay in Eau Claire, transfer to Eau Claire. So also after we do the research, after I do this research with my students, and then I recommend them going to different places to present their talk, present their results. This will help them to improve their oral skills. This will build their confidence. There are several research dissemination opportunities versus National Conference on Undergraduate Research, and you have Seven Rivers Undergraduate Research Symposium, you have a Systems Symposium and a research posted in Rotunda, and MA section meeting, you have Eau Claire Provost Honors Symposium and Circa. And I do have students presenting in Circa, as you can see. And I also have one student who present this year in 2020, I think in 2020, in Madison in March, I think it's March the 7th. I remember it's March the 7th or March the 11th in 2020. He presented, right now the student is in Madison. And also I also encourage students to write down their results and write down their work. And then in the end, we can submit it to some undergraduate research journal and publish it. So this is basically what I do with my students at Barron County. And if any students at Eau Claire, if you watch this video, I know some of you are not be able to attend this presentation today. But if you watch this presentation, if you really want to join my team on some of the activities, some of the projects, feel free to email me or contact me or let me know if you are interested. And I'm here on Monday and Wednesday this semester, but we can meet online for sure. And right now I have one student from Eau Claire is doing research with me. So this is all my talk, and thank you very much.
Well, thank you, Dr. Tian, for the wonderful presentation and a host of very, very interesting projects, I might add. Do we have questions from the audience?
Yes, I see. Caroline asked me I would add the National Joint Math. Yeah. National Joint Math Meeting. Yeah, this year is virtual. Yes, right. That's right. I'll add that into. Oh, I can't add it anymore, but we know it is. There's another opportunity to present the student result, which is the National Joint Math Meeting. I didn't put it there. I forgot that. Yes. I have a couple of math, so we would add to the list. Yeah, thank you, Caroline. I don't know all the full list of the undergraduate journals, but if we can compile that and share with all the faculty at the math department, I don't know. I mean, that may be a good idea. At Barron County, I have a math club, which is called Undergraduate Mathematics and its Application Club. And I'm the advisor of the club, and we have students who is interested in doing some research, undergraduate research, and then they come. Well, everyone is welcome. It's not just the student who really wants to do math. Then if they don't, they can just come to have fun. Yeah. I think Eau Claire also have this, right? Eau Claire campus also have the club. I don't know. This is my first semester teaching at Eau Claire. So that's how I recruit students at at Barron County. So at Eau Claire, I'm thinking maybe if I have some of those organizations, some of those clubs or student organization, maybe we can do something like that. Or maybe I can give a talk and recruit students to do those activities as well. Yeah.
Yeah, I'm sure each department or each program will have their own way of recruiting students, but I believe student clubs, or even sometimes sending a message through the instructor of various courses that you think are appropriate for recruiting, or even spending a couple of minutes in the class in the beginning of a class. I think those are kind of common strategies.
Yes. Oh, Caroline just said we do have math club, actuarial club, and data science club. That's really good. Eau Claire have 10,000 students. I hope like we can get some students together to work on to participate in some of those projects or contests or activities. And it's really helpful. For example, the Amazon review system. After the student after finish the whole project, they have a bad idea of okay. So if they go for an interview for other companies, they can tell that interviewers tells, hey, I did this project. I can do this to help you. What I'm going to do in this review is really important because everyone has review, right? Not just Amazon. A lot of places have reviews. Even when teaching class, we have review, right? So that's important. The students learn a lot from this project because when they go to find an internship, they can tell what they can do for the company. So I think it's a good opportunity for UW ECB and really working joint as a project since we have all the online community. Yeah, I think so. Yeah, I think that would be a great opportunity to do that. Yes. Well, I always bring the students to Eau Claire when there is a talk like Circa. We have that. We have Impact. I brought students to Mayo, Connecticut to present. Yeah. I hope maybe in the future, because if I'm here more, I can probably do more projects with the students at Eau Claire. Right now I have one student. Not only I have one, which is really good. I have one student at Eau Claire math department. I think his major is math or statistics. Her actually is a female student. Yeah, she is interested. She's doing one of the projects with me right now. Yeah. So actually, it's not just math. It's math. When you're talking about writing a paper, it's just not one student. It's several students. I need some student who can do programming, like computer science. When you do the data science, it's programming. You have to use Python to sort the data, find out the data, right? So it's kind of like students have to use MATLAB to graph some of your pictures. And so when it's really not just the math, it has maybe other majors like business major. They have a better idea of the business area, business field, how it should be, how do we need to present our result in the aspect of business, right? Yeah.
So I hate to interrupt this very interesting discussion, but just be mindful of time. So I think we should close up. But I think we all agree that Dr. Tian has a host of very interesting projects, many of which are application based and crosses boundaries of various disciplines. So it's not just about math.
So, you don't see many equations, right? Yes.
Right. So I think, I encourage everybody to think about where their interest lies and whether it will align with some aspects of various possible projects. But just to be mindful of time, I think this is all the time we have today. For folks who are interested in more information about these projects, please contact Dr. Tian. Thank you very much for your presentation, and thank you everybody for coming.
Thank you. Thank you very much.